I'm Alan Benner. I work at IBM on architecture of networks and servers for high-performance computing. IBM has been at the Supercomputing conference since the first one back 25 years ago, and because IBM is one of the few companies that has been with the conference for the last 25 years, we wanted to put together a timeline of the innovations that IBM has contributed to supercomputing over that time, and also for the time previous to that, back to more than 50 years of IBM's existence. When we put this timeline together, we also put together hardware artifacts of pieces of computers that stretch back to the late 80s and also even earlier, back to the 60s and 50s, from the IBM archives and also from engineers' souvenir collections that they have in their offices. So it's neat to see how the computers were built back then. They seem quaint and the problems seem quaint compared to current things, but it's nice to see computers from when you can actually understand how the individual parts worked by looking at them. Back in the 50s and 60s was the semi-automated ground environment, or SAGE computers, which IBM built for the National Air Defense System to do the equivalent of air traffic control, radar processing, interactively trying to help people understand whether or not there were airborne threats coming over from the Soviet Union. These days, our big problems are in cognitive computing systems, trying to help medical professionals diagnose cancer and other diseases. So not only the technology has changed, but also the problems have changed in the 50 years since then. In the late 80s, the highest performance computing at that time out of IBM was the vector facilities, which was an additional facility for the highest end of the mainframe systems at the time that could do an equivalent of 500 million floating point operations per second for only a few $1 million. These days, we're able to do 20 peta operations per second for a few tens of billions of dollars. So the difference at the time has been a 40 million or more, actually more than 40 million, improvement in the scale of system capabilities, and a more than 1 million times improvement in the cost competitiveness, price competitiveness of the systems at all scales of the system. So not only the technologies, but the system scale has improved a lot in that time. In the early 90s, we had the development of the SP1 and SP2 systems, which pioneered the concept of building a high-performance computing system out of standard off-the-shelf server computers with some special packaging and some special high-performance interconnect capability that would allow lots of servers to be integrated into a unified, integrated high-performance computing system. And that same type of architecture has continued on to these days in all types of systems with variations and modifications. So that same kind of model is still very relevant. When we put the timeline together, we concentrated primarily on the customer systems, the particular installations at particular IBM clients that highlighted the disruptive improvements in system capabilities or cost performance at the time, from the SP1 and SP2 installations through Deep Blue, the power installations, the Roadrunner blade systems, and up through Watson most recently. And we also put together a timeline of the technologies that have gone into being able to build these systems at all scales of the computing hierarchy, from the silicon area and CMOS, interconnect, up through the processors, the interconnect fabrics, the software at all levels, from APIs and storage softwares and system management capabilities, and the platform computing things for managing whole clusters of systems, and then also the products that have been put together, power systems, Blue Gene systems, and X-Series systems to be able to build these systems with. In the future, what's going to happen next, I don't know. But I do expect that 25 years from now, there will be an SC38, and I do expect that IBM will be there. I don't know how we're going to get here, maybe flying cars or neural implants, but I would bet on people actually coming to a place, maybe Denver again, and talking about how the high-performance computing history has evolved over the last 5 decades, and I expect IBM will be a big part of that. Thank you for joining us at the IBM booth here in Denver, Colorado at the 25th anniversary of SC.